Hello, welcome to pre-maths lesson. Today we're going to be looking at transformation. First, we're going to look at enlargement, then rotation, then reflections, and then the last, a translation. Without delay, let's get started. So first, we're looking at enlargement. When you're enlarging a shape, there are three things you need to consider. One is the word enlargement, what the word enlargement means. The secondly, what the scale factor. Scale factor is how many times you make in the shape bigger or smaller. And the third is the center, that what we need to consider. So first, let's say if you want to make this shape here, that's 3 by 2 rectangle or 2 by 3 rectangle 2 times bigger. Okay, so we're going to multiply this length here by 2 and that'll give you 6. So you make the height of that rectangle 6 rather than 3, and multiply this length here by 2 as well. So the length of the rectangle will become 4, and then you create the rectangle and it'll give you 6 by 4 rectangle. Right, so enlargement is the word when you're making shapes bigger or smaller. Scale factor is how many times you're making it bigger. So in this case, the scale factor is 2, and the center is not involved in this case. So we're just going to say we enlarge the shape by scale factor 2. So we multiply every single length by 2 and recreate that shape, and it would look something like that. So your image would be 6 across, 4 up, 6 across. So enlarge this shape by scale factor 2. So you make this shape 2 times bigger by multiplying every single length by 2. Another example, we got the object that's got length 2. That length there is 3. And at length at the bottom is 1. So this time we're making the shape 3 times bigger. Why? Because the scale factor, how many times that shape's going to be bigger, how many times the image going to be bigger, is given to us by 3 here. So we're enlarging that scale by scale factor 3. So we first multiply each length by 3. So we need 2 multiplied by 3, that will give us 6. And then 3 multiplied by 3, that give us 9, and then 1 multiplied by 3, that'll give us 3. So we need to draw those 3 lengths, and once you get all those lengths, right at the end we need to connect these 2 points together to create an image that looks similar to what we had in an object, just 3 times bigger. So every single length has to be multiplied by 3. Here's another example we're going to be using where we're enlarging the shape by scale factor 3, making this shape here 3 times bigger. And what you notice here is a kite. This shape here is kite. These two lengths are exactly this. These two lengths are exactly this, and they all diagonal lengths. So that's why it's slightly difficult to make it 3 times bigger. And I chose this on purpose. So what we're gonna do, we're gonna try and find out. Start with one of the points. I label these points A, B, C, and D. So we're gonna pick one of the point. Let's say we gotta pick the point A somewhere here. So that's our point in image. That's point A on an image. Now from the A to B, what we're doing, because this is still fairly nice because you're going diagonally one diagonal, okay, down. But what we generally measure is saying from A to B, I'm going 1 across, so 1 to the right and 1 down. And we're making it 3 times bigger because the scale factor is 3. So we're going to, from the A prime, we're going to be going 3 points to the right and 3 points down. So we go 1, 2, 3, 1, 2, 3. So this is where your B prime is going to be. Okay. So you can see there's a 3 diagonal will take you to B. Then from B to C, I'm going 2 down, 1 and 2. So we're going 2 down and 1 to the left. So B to C, I'm going to triple that distance. Okay. So multiply that by 3. Why? Because the scale factor is 3. Multiply that by 3. Why? Because the scale factor is 3. So instead of going 2 down, we're going to go 6 down and 3 to the left. Okay. So from B, I'm going to go 6 down, 1, 2, 3, 4, 5, 6, and then 3 to the left, 1, 2, and 3, and it should come exactly underneath your A prime. So this is what our point is going to be, C prime. And then from C, obviously we're going 3 right, because instead of 1 left and 2 up, we're going to go 3 left and 6 up. So you're going 1, 2, 3, 1, 2, 3, 4, 5, and 6. And that should be in the same line as B as well, because these two B and D are in the same line. So this is our coordinate D prime. So what we get here is an image. So our original shape is an object. After transformation is image. So this image is 3 times bigger than the objects. Why? Because we enlarged that by scale factor 3. So here's another example. And this time we're going to be looking at center as well as the scale factor when we're enlarging a shape. We've been given the scale factor, which is 2. That means we're making it 2 times bigger. But we've been also given the center. So this is where we're making the shape bigger from. So if we're making the shape bigger from here, we need to count distance to each one of these points from the center. To go from center to A, we're looking at 1 to the right and 1 down. And if you're making it 2 times bigger, what we're going to do is we're going to go 2 to the right and 2 down. So this one here, that A will move here. Okay, this point here, A, that will move here. And let's call this point B. So to go from center to B, we're going 2 to the right and 1 down. So we double that because the scale factor is 2. So we're going 4 to the right and 2 down. So this point here would be your B prime. So that's your A prime. This is your B prime. Now again, we continue. Let's say we need to go to this shape here on the object. So this point, we're going 2 across, 2 down. So from the center, we double that distance. We're going 4 across, 4 down. To get to this point here, from the center, we're going 1 to the right and 3 down. So double that, 2 to the right and 6 down. To get to this point, we're going 3 across, 2 down. So double that, we're going to go 6 across, so 6 across, 4 down. So that's that point there. And again, now we can actually recreate that if we wanted to, but we can just keep on going. From the center to this point here, we need to go 3 to the right and 3 down. So double that, 6 to the right and 6 down. But what else we can do here is actually once you find one of the points, then we double each one of those distance. From A to B, I'm going 1 to the right. So from A prime to B prime, I'm going to double that and I'll get 2 to the right. From B to this point here, we 2 down and then 2 across, then 2 down, and we get this. Join all the points together and what you get, we call a image. So that was our object and that's our image. Now image is exactly 2 times bigger than object and we use the center. So we made this image 2 times bigger from this center. And what does that mean in terms of the center? Okay, so if I draw the lines from the center to this point, that's, let's call it a C, and that would be C prime. So when you join them up, that would be in the straight line. Your A and A prime would be in the same straight line if with the center. That B and B prime would be in the same straight line from the center if you join them up. Even if you don't have the grid in there, we can measure the distances and that would be exactly the same. This one here is roughly 3 centimeter. So that point is double that distance. So the 6.5 centimeter from there. The center could be given to you as a coordinate. So here, if you read the questions carefully, we're enlarging a shape by scale factor 3. So again, making the shape 3 times bigger from the coordinates that given to us as a -6 and -4. Okay, so we find the center -6, -4 first, and when you do that, or measure the distance from the center to the points on the object. So that's our center of enlargement, and when you measure the distance to that point, we're going 2 to the right and 2 up. Again, because the scale factor is 3, we're multiplying each one of those distance from the center to that point needs to be tripled. Okay, so we, instead of going 2 right, we're going to go 6 right, and instead of going 2 up, we're going to go 6 up. So that'll give us that new point. We do the same thing for all 4 of those points. 3 across and 1 up, so we triple that distance. So we got 9 across and 3 up. And then again to the next point, we're going 4 across and 2 up, so we triple that. So we're going to need to go 12 to the right and 6 up. And then the last point, we're going 3 to the right and 3 up. We triple that, so we go 9 to the right and 9 up. And what we get is our image. Pause the video and try and have a go at these questions. They are drawn on the centimeter by centimeter grid, so you can replicate it, and there is a center has been given to you for each one of those points. So use that center. So again, if I were to draw it in my book, I'm going to draw the center, then the 1 across, 2 up. You start your first point and then draw the 2 by 3 rectangle and enlarge it by the scale factor 2. When you're ready, press play. So those are the answers on here. Enlargement doesn't necessarily mean making things bigger. You can actually make things smaller as well. When you use the scale factor, that's not a whole number. If you're using a scale factor that's a half, for this example here, then we're making things smaller. Okay, so we again using the coordinate to be our center, so we're going to be looking at coordinate 4, 3. That means 4 on the x-axis and -3 on the y-axis. So we mark our center. That's our center of enlargement, and then we need to measure the distance from the center to each point on the object. And then we half that, means divided by 2. Whatever the distance we get, we divide it by 2. So we're going 10 to the left and 6 up. We half that distance, so we need to be going 5 to the left and 3 up. Pick another point. We're going 9 to the left and 9 up, so we half that. We're going 4.5 to the left and 4.5 up. The third point, 7 to the left and 9 up, so we're doing 3.5 left and 4.5 up. And the last point, 6 to the left and 8 up, so we're going to go through 3 to the left and 3 up. So we get our image, which is half the size of the object. Enlarged it by scale factor half. Enlarge the shape by scale factor half from the center given to us here. So what we're first going to do is count the square from the center to one of the points on this object here. Let's call these 3 points as A, B, and C. On the objects we have 3 points A, B, and C, and we need to locate A, B, and C on the image. To do that, we need to use the scale factor. So from the center to B, I'm going 1, 2, 3, 4 to the right, and 1, 2, 3, 4, 4 up. So we're going 1, 2, 3, 4, 1, 2, 3, and 4. So that distance there is 4, that distance there is 4. And the scale factor we've been given is half. That means we need to half the distance from the center to the point B. So we multiply that by half, we get 2. We multiply this distance here by half and we get 2. So instead of going from the center 4 across and 4 up, we're going to go 2 to the right and 2 up. So we're going 1 and 2 right and 1 and 2 up. So what we get here is our B prime. Then from B to A on the object, I can do that. From B to A, I'm going 1, 2, 3, 4. So on B prime to A prime, I need to go 1 and 2, half that distance. So I'm going to be making this shape here half the size. So we get there 2, and that will give you your A prime. And then from B to C, I'm going 1, 2, 3, 4, 5, and 6 up. So we half that distance. So we end up going only 3 up. 1, 2, and 3 up. And that would be your C prime. So once you found your A prime, B prime, and C prime, we can join them up. That's our image, and it's a half the size of the object. If you draw the line of enlargement, so from the center to C prime, they're going to be in that same straight line. Center to A prime, they are going to be in that same straight line. And these are called lines of enlargement. B prime, and the center should be in the same straight line as well. So anytime you enlarge the shape and draw these lines of enlargement, your enlarged shape and the object should be within those straight lines. So here's some questions that you can have a go at it. What does it mean by scale factor -1? That's what we're going to be looking at. So, but when you're doing the negative scale factor, we need to again count the distance between the center and each one of these points on the objects are. So from the center to, let's say we call this one again A, B, and C. So from center to B, we're going 2 right, 2 up. Okay. So 2 to the right and 2 up to go from center to B. And the scale factor is -1. So what do we have to do? We need to multiply each one of those lengths by -1. Okay. So we're multiplying 2 right by -1, we get -2. And multiply 2 up by -1, we get -2 again. So instead of going 2 right, -2 means we need to go 2 left. So we go there, and instead of going 2 up, we're going to go -2. So that means we're going 2 down. Okay. So this will become your B prime. Same thing for the A. When you're using negative scale factor, I'd like you to just go through all the points. Okay. Multiply by -1 so you'll be able to see it. Otherwise you end up drawing it wrong way round. Okay. So to go to A, from the center, we're going 2 to the right and 3 up. So instead, we're going to go 2 to the left and 3 down. So this will become your A prime. And to go to C, I'm going 4 to the right and 2 up. So instead, I'm going to go 4 to the left and 2 down. So that would be your C prime. So when you draw that shape, this is what it looked like. So C and C prime are in the same straight line going through the center. B and B prime are in the same straight line going through the center, and A and A prime are in the same straight line going through the center. So this is our -1, scale factor -1, where we're enlarging this shape here by scale factor -2. So exactly the same thing. Here we got the center. From center to point A, we're going 1 right, 1 up. 1 right, 1 up. And the scale factor is -2. So we need to multiply by -2. So we get -2 to the right, -2 up. What does that mean? You're going 1 and 2 to the left and 2 down. So that's where you end up with your point A, which we call it A prime. Okay. And exactly the same thing again. To go to the point B, I'm going 1, 2, 3, 4. 4 to the right and 1 up. So instead we're going 4 to the right we multiply that by -2, we're going to be going 8 to the left and 2 down. So 1, 2, 3, 4, 5, 6, 7 and 8, 1 and 2. So this is where we end up with. Okay, so this is our B prime. Then go to the this point here. We're going 1 right, 2 up. We're gonna go 2 right, 4 down. So that's this point here, and then go to the point C. I'm going 4 right and 3 up. So I need to double that distance. So you're going 8 right and 6 down. And that will give you your C prime. And then you can recreate it if you want to. I'm going 1 left from the C. So I need to go 2 to the right from C. So that'll create that point. And then from there, I'm going 1 down. So I need to go 2 up. That'll create this point. And we already have that point. So we created enlarged shape. That is a scale factor by -2. And this is bigger in size, but you can see the orientation has changed here. It's not in the same facing same direction. It's almost like we reflected the shape. Okay, or so it's 2 times bigger, or we can say we rotated the shape basically almost 180 degree and then made it 2 times bigger. Okay, so that's our image. So when you have a negative scale factor, it probably look like a reflected. But again, if you join A with A prime, that will make that straight line going through the center. If I join B with B prime, that would be going through the center and make a straight line. If I join C with C prime, that would be going through the center and make a straight line. Every single point on that shape should be making straight line with the image. Okay, and it should be going through the center. The last type of question that we need to look at, what happens when you have to describe the transformation and it's an enlargement. So when you're describing a transformation, you will have to tell them that it's an enlargement. So as long as the shape are not the same size, it's going to be enlargement. So these two shapes are not the same size, so it's an enlargement. That will get you your first mark. Then you need to tell me what the scale factor is. So you can easily figure that out. So scale factor there is as long as we know this is an image, okay, and that's object. So the length of the image there is 4, the length of the object is 2. So all we need to do to work out the scale factor, we're doing 4 divided by 2, that gives you 2. So from the objects, we made the object 2 times bigger to get the image. So the scale factor is equal to 2. That'll get you the second mark. And then we'll have to find the center, where the center is, and that will get you your third mark. To find the center, make sure you draw the line that goes through the same points on the image and the same point on the object. So draw the straight line going through those 2 points. And then draw the same straight line going through these 2 points or these 2 points. And what you'll notice, all 3 of these line of enlargement are going through this point, and that is our center of an enlargement. Okay, so this is where we're enlarging it from, and once you get there, you write down the coordinates for center. So center is 2 across. So you always go along the corridor and then up the stair. So 2 to the right and then 1 up. So there's 2 across and 1 up. So 2, 1. Center is the coordinate 2, 1. And we're going on to rotation now. So we need to understand what rotation is first. So when you're rotating a shape, there are 3 things that will come in. If I'm rotating this marker here, so that's a 90-degree rotation from this point here. That point's not moving. Everything else is moving. That point is not moving. Now I can rotate it if it's attached to a string or something. I can rotate it, and this is also 90-degree rotation. But where you're rotating it from, it changes. So the three things that's important in the rotation, one of those, this. So direction. So which way I'm going? Clockwise or anti-clockwise? How far am I going? What angle am I rotating it from? Okay, 90 degree, 180 degree, 270 degree. And if it's full round, obviously there is no point them asking you the question. So rotate it 360 degree and it will come back to itself, original position. And center of rotation, where you're rotating it from. So I can rotate it from here, then it'll look like that. If I rotate it from the center where I'm holding it, then it'll do that. Okay. So it depends where you're rotating it from. So those three things are we need to be looking at: direction, angle, and the center. So again, look at this shape here. We're rotating it from the origin, 0, 0. So that A goes to A prime here. And the rotation that I'll take is that much, which is 90-degree angle between that straight line and this straight line. And you can draw the straight line between any of these points and it would have created 90-degree angle. If I rotate that shape 180 degrees, where would it land? A, B, C, or D? That's right, it would be on D. And again, it's upside down smiley face. When you rotate it, orientation changes. Okay, orientation means that what it looks like. Okay, that's orientation, changing it. So I'm rotating it or turning it around. That's why its orientation changes. Again, where would that triangle be if you rotate it 90-degree clockwise? 90-degree clockwise means you're going that way, 90 degree. So would it be on D, B, or A? Where would it be if you rotate it 90-degree anti-clockwise? The same triangle, we're going anti-clockwise now. Would it be on the B or C? That's right, it is on C. Now the center of rotation changed. So we won't always have the center of rotation to be 0, 0. It's this time here. That's our center of rotation. Where would that square going to be if you rotate it 90-degree anti-clockwise? A, C, or B? That's right, it is A. Rotate 90-degree anti-clockwise from the center that's been given to us here. Okay. So the first thing we need to do when you're rotating shape, put the tracing paper over the shape and the center. Make sure you cover the center and the shape. So I'm going to mark the center first. I'm going to draw the line or arrow pointing up the page. We can do it sideways as well. Again, if you're not sure, make sure you line it up properly. The reason I did that arrow pointing up, when I'm rotating the shape, I need to make sure that when it complete the 90-degree rotation, I need to stop. So 90-degree rotation would be when that arrow here lines up with this line here. Then I would have completed my 90-degree rotation there. Okay. So what we're going to do is, once you've done that, I'm going to mark these points. Some people sketches the entire shape. I'm going to mark these key points here. Now what I'm going to do is hold the pen, hold the center with the pen. So it needs to be sharp end basically. With the pen, and then rotate your tracing paper until the arrow matches the side line. Okay, and these points generally would be on the right places. So can you see where that is? The arrow now pointing the sideway, and all of these points being matched with the certain points. So again, you can go over these with the pen, or you can remember it where they are and then start drawing it. So okay, so from the center, the bottom end of that arrow would be 2 places away, and in the long length of the arrow is in the same line as this one here. Okay, so I'm going to try and replicate it. 2 places away, that's the bottom end, and then from there I'm going 2 up, 2 up. It's in that same line, 1 across, 1 across, that one and that one. So this is our image when you complete drawing it, and what we get is our image. So we rotated that shape 90 degree, and remember we've been asked to do it anti-clockwise. Okay, so when you rotate it at 90 degree, remember that's the same point on that, that's the same point. When you join them up to the center, that would be creating 90 degree angle. Rotate the shape clockwise 90 degree about the point 1, 2. So first we mark the center. So we marked our center there, which is 1, 2. 1 across, 2 up. And then what you need to do is use a tracing paper. As we talked about it earlier, sketch the shape. And then hold the tracing paper where the center is, and then turn it around. But what I would do generally before we actually start turning it around, I mark the point with the arrow pointing upward. Why? Because I want to know when the arrow lines up with this line here, that will complete the 90 degree rotation. Okay, so I would generally do the point, draw the arrow pointing upwards like we already discussed it, and then hold the tracing paper at the center and rotate the tracing paper 90 degrees, so until the arrow matches up. So I'd like you to pause the video and have a go at these questions. When you're ready, press play. So there's the last type of questions on the rotation, is you will have to describe the rotation. So when you're describing it, you need to tell me what type of transformation it is. Okay, out of those 4 that we mentioned earlier, is it enlargement, is it rotation, is it reflection, or is it translation? So if you think it's rotation, state it. It's a rotation and you will get 1 mark. You will get 1 mark. Then once you know it's a rotation, you need to tell me the angle and the direction. Okay, so you're going from A to B. So A is your object and B is your image. So if I go from A to B, I'm going clockwise. But how many degrees? That's pointing up the page, and that's pointing side of the page. Okay, so you're doing 90 degree clockwise. So that would get you your second mark. It's a rotation and you're turning it 90 degree clockwise. And then you need to decide where the center is. Okay, and generally center comes from playing around with the tracing paper. You draw the shape object on the tracing paper, trying to hold different point with the pen and trying to match it. They generally same distance away from the same point. So if I'm looking at this, these 2 are the points, then they'll be exactly the same distance away, which turns out to be origin. If I draw the line here and the line here, they would make 90 degree angle between them. So we got everything we needed now. Okay, we know it's a 90 degree rotation clockwise about the point 0, 0, which is also known as origin. But this can also be looked at as a reflection in the line x plus y equal to 4, I think. Yeah, but we're just going to look at it as a rotation. Okay, so we know it's a rotation. It's a 180 degree rotation. Center of rotation is where those 2 points meet, because they are touching. So we know that is going to be the center of rotation. Trying to have a go at these questions. Pause the video and have a go at these questions. When you're ready, press play. So quick fire questions. Can you describe the rotation from blue to red? So I know it's 90 degree clockwise. Yes. That would be, yes, 180 degree. (90° clockwise). 180 degree. 90° anti-clockwise. And the point is this one here. Before we need to start a reflection, we need to look at some key knowledge. One of those key knowledge we need to look at is definition of polygon. What is a polygon? Okay, so polygon has to be closed shape. Okay? Closed shape means there shouldn't be any gaps. So that's not a polygon. Okay, it has to be closed shape. So we got 3 closed shapes, 1, 2, and 3. That's not a polygon either. Why is that not a polygon? Because the polygon has to have a straight line. Straight lines and the closed shape, then it's a polygon. So that's a polygon and that's a polygon. So that covers the definition of a polygon. Then we need to be able to know what regular polygon is. Okay, regular polygon has same sides, same length, and the same angles. Whereas this one here, all 6 sides are same length, and you can see from these symbol here. These 3 lengths are exactly the same, but we also need to have the same angle. So these angles are the same as well. Whereas in the equilateral triangle, all 3 angles going to be 60 degree as well. So these 2 are the regular polygon. This one is not a regular polygon. Okay, that's a parallelogram, hexagon, and equilateral triangle. Another question that could come up is regular and irregular. So what we got here is a regular, and that's irregular. Okay, so not regular polygon. So both are pentagons. It's got 5 sides, so therefore they're both pentagons. One of them is regular, one of them is irregular. Do all pentagons have at least one line of symmetry? The answer is no. Not all pentagons have one line of symmetry. So one of the things we need to know is to be able to draw straight lines. Not necessarily all the straight lines. So the lines that's parallel to y-axis, then the lines that's parallel to x-axis. So we should be able to draw these lines. So let's try looking at it. Okay, so what if I ask you to plot the point where x is equal to 1? Can you find a place where x is equal to 1? And majority would be able to do that, and it tells me this is where the x is equal to 1. And I ask you saying, okay, where else do you see the x is equal to 1? So you can see these points. Once you get started, then you can find all the possible points where the x is equal to 1, saying, okay, x is equal to 1 on all those places and all the places below the x-axis as well. Okay, this is where x value is always going to be 1. Can you find more places where x is equal to 1? Okay, and yes, the answer is yes. You can find the x is equal to 1 between those 2 crosses as well. Okay, so if I draw a straight line there, any point you pick on that straight line, x value will be equal to 1. And that's why this line here is known as a x equal to 1. If I ask you now to draw the line y equal to 2, so we would have some idea saying, okay, I need to draw the line where y is equal to 2. So I'll mark a point where y is equal to 2. This is where y is equal to 2. And you can mark a few other points where y is equal to 2. And you'll find out that every point on this green line here, doesn't matter where you pick the point, that point there, 4 across, 2 up. So y value will always going to be 2. Okay, because when you write the coordinates, you always write the coordinate as a x and then the y. The second value in the coordinate is your y value. So on the green line, every single value on the green line, y coordinates is going to be 2. So therefore, that line is known as a y equal to 2. So obviously, for the same reasoning, I can work out where the x equal to -3 going to be. So you find x equal to -3 and then draw the line through that. So this orange line is going to be x equal to -3. The same way y equal to -5 is going to be this purple line. And the x equal to 0, where you find the x is equal to 0 there, which is our y-axis. So I'd like you to pause the video and have a go at these questions yourself. If you can draw these lines, then we shouldn't have a massive problem going through the reflection questions. Okay, so it all depends on whether you be able to draw the straight line graphs or not. Whenever you're ready, press play. Alright, okay, so we can draw these lines. All of those lines are going through the x-axis. Okay, so we're going through the x equal to 2, that's the line. And x equal to 5 would be going through where the x is 5, the vertical line. X equal to -1 would be going through there. And x equal to -3 would be going through there. So we already labeled this. Then this one is going to be x equal to -3, which is there. This one here is x equal to -2.5. And the same way, if I ask you to draw these graphs, y equal to 2, so y equal to 2 would be there. Y equal to -1 would be here, and y equal to -4 would be right at the bottom. And then y equal to 0.5 would be there. Okay. Make sure you label all the lines. Every time you have to draw the line, make sure you label it. This line here is called the mirror line or line of the reflection. So there's two names for it, mirror line or line of reflection. So it's really straightforward. If I'm looking at each point here again, so this point here is distance 3 squares away from the line of reflection. So if I need to go to this point from the line of reflection, I'm going 3 square. So I see that point on the other side 3 square away. So that would be that point. This point here is 2 points away from the line of reflection. So I'm going to go 2 points away this way. So that point is going to be there. Remember, one thing you need to remember, the distance you measure has to be 90-degree angle perpendicular to the line of reflection. Okay, you can't just go 3 square away in any direction. It has to be 90-degree away. This point here is 2 again, so that line here is going to be 2 as well. And that one is 4. So this point here is going to be 4 as well. They all make a 90-degree angle. So we already found the shape. And that would create exactly identical shape on the other side. If I fold this piece of paper in the line of reflection, which is in the center there, this shape here, which we call image, fits exactly on top of the object. Okay, so object and image will fold onto each other. Okay, it's like this, fold onto exactly matching. So there's a line of reflection in the middle there. Okay, if I have this 2 pans there, fold it onto each other. It folds onto each other. Then there's a line of reflection going in the middle there, where my two thumbs touch it. Okay, so that always happens. If you fold the paper in the line of reflection, it will always fold onto itself. Okay. So we're looking to reflect this shape here in the line of reflection. This dotted line here is our line of reflection. So we can do exactly the same thing again. Count the squares, 2 squares away. So you go 2 square to the left. Opposite direction, exactly the same distance away. This one is now 1 box above, 4 square away. So I go 4 square from that direction. This point here is again 4 square away. And that point is 2 square away. We got our shape here, which is image. Now, that's not the only way you can do that. You can also use a tracing paper. Why do we need to use a tracing paper? Because these line of reflection not always going to be vertical or horizontal. Okay, it can be diagonal as well. Okay, and when it's diagonal line, it's slightly difficult to count the squares because you won't be able to count the square if it's going that way. Okay, So you need to be slightly careful. So what we're going to do is we're going to take a tracing paper and use the tracing paper to reflect the shape. But before we actually start using the tracing paper, we need to mark a point on the line of reflection. I'll explain why. So we're going to mark this point here on the line of reflection. Okay. So when you put the tracing paper over the shape, make sure it covers the line of reflection and the shape. So first thing I'm going to do, I'm going to the marked point, and then you can sketch a few other things on that as well in the tracing paper, line of reflection, and then we put our point of the key points of the shape on the tracing paper. I generally prefer to just do the points and then trace the shape afterward. Then all we're doing is, if you're reflecting it, remember the reflection is movement that goes that way. Okay, it's just flipping it over on the line. So all I'm doing is turning that tracing paper over and then matching it with the line of reflection. And you can see from the line, okay, they're not exactly on top. Why? Because they've not been matched whether we did that crossing point. If I match the crossing points, then they will be exactly on top of where our reflected point was. Okay, reflected points were on the image. So this is the reason you need to mark that crossing point, or just mark a point on the line of reflection. So when you turn the tracing paper over, you don't go slightly up or slightly below. Okay, so it would be exactly where it's supposed to be, 90-degree angle perpendicular to the line of reflection. We can look at some different type of questions here. So here what we've been given is reflect the triangle in the y-axis and in the line y equal to x. So these are the standard 2-mark questions in the exams. So first we need to find out where the y-axis is. Y-axis is this one here. So we need to reflect this triangle in this line here. Okay. So y-axis also known as x equal to 0 line, because the x value here is 0, and if you put any points on that line, x value would always going to be 0. So there are two different ways you can write this: y-axis or line x equal to 0. Okay. So when you reflect it, mark each point, each coordinate, and needs to be exactly same distance away from the y-axis. So 2 and 4, and that would be 4 as well. So when you draw the triangle, this is what the triangle looks like. Okay. Same thing, draw the line y equal to 1. So we already looked at it, how to draw the lines y equal to 1. So y equal to 1 line would be going through here. So we mark the y equal to 1 line and then reflect that shape exactly the same distance away, and it would be reflected. This one here is in the diagonal lines, like I said. Okay, we also need to know the equation of the diagonal line as well, but we're going to look at it next. Okay, so when you're looking at the diagonal lines exactly the same way, you can use the tracing paper if you're not sure. Otherwise, you can do the diagonal line exactly the same way. So from the point here, the distance to the line is a half a square. Okay, in diagonally, because we need to make sure that it makes 90-degree angle. Okay, so distance to that, from that point to there, is at 90-degree, and 90 degrees goes there. Okay. The same thing with the other one as well. All 3 points goes there. So when you fold that triangle or fold that piece of paper into this line here, okay, it should match onto the other side. Okay, there is a common mistake that we see. I'm trying to look at it in the next few questions. Okay, reflect the rectangle in the line y equal to x. We haven't looked at what the line y equal to x looks like. Okay, so we're going to try and draw that line from the scratch. So y equal to x line. So when you write your coordinates down, you always write here as this, x and then the y. So if the y value and the x value are exactly the same, give me any coordinates where y value and x value are going to be the same. So you can start with 0, 0. X is exactly same as y. So obviously now you can come up with more. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So as long as you draw 2 coordinates, you can draw a straight line. So one of the point we said was there, and there, and there, and so on. So if you draw a straight line through that, that is your line y equal to x, because every point on this line, y value going to be exactly same as x value. It could be 0.25, and 0.25, which is somewhere here. Okay, so every single point on that line, X value is going to be exactly the same as Y value. All we need to do now is reflect it. Again, you can use a tracing paper to reflect that shape, or you can measure it diagonally, okay, which makes 90-degree angle to our line. So if you fold this shape into this line of reflection, this object should match exactly on top of the image. Again, think about it this way, okay? There's a diagonal line there. When I fold it, it should match. Okay. Fold it, it should match. Fold it, it should match. Right, so here's, have a look at some of the example of the reflection in the diagonal line. So you will have some idea, because once you looked at few examples yourself, then you know if you go wrong. So these are reflection done in the diagonal lines. Okay, these are the same again. The red shape reflects onto the blue, or you can say blue reflects onto the red one. So if you fold into that line, that blue triangle maps onto the red, and so on. So you can see all of these, even if they're not touching the line of reflection. Can you see how this green one will map onto this blue one, okay, when you fold it onto the line of reflection? Have a look at a few more. Which one of those are wrong? You need to find out. Some of those are done wrong, common mistakes. Okay, pause the video. When you're ready, press play. Right, you can see there's a mistake, obvious mistake here. That point is, it doesn't go all the way up to there. And again, if you do that in the exam, you would lose all the marks here. Okay, so obvious mistake there, should have been there. Okay, that one was the problem here. From the line of reflection here, the red square is touching the line of reflection, whereas that one is one square away from the line of reflection. So it should have been starting from there. They're actually correct, this one is. Okay, so they would fold onto each other. So that's correct. This is the common mistake people make. That's touching the line of reflection. So remember, what part of the arrow touching the line of reflection? It should be this part there, facing that way. Okay, because it's a reflection. It's not looking at, if you look at the mirror, you see your face. You don't see back of your head. Okay, you would see your face. So this is like this person here, object looking into mirror, and they see the back of their head. So think about it that way. So common mistake, try and avoid it. That seems correct to me. That's another common mistake that people make. So your triangle should be there. Last part of the transformation is translation. So how are we going to look at the translation? So a couple of questions to start off, how to describe translation. Okay, so first, we already looked at the coordinates. So what are the coordinates of these 3 points? We got A is 2, 1, because 2 across and 1 up. B is 2, negative 2, and then C is negative 2 and negative 2. Describe A to B. If I go from A to B, 3 square down. You're going 3 square down. And if you go from B to C, you're moving 4 square to the left. And if you're going from A to C or C to A, I'm going 4 square to the right and 3 square up. And that is what translation is. Moving one thing to different position. So your orientation, you're not rotating it, you're not reflecting it. Orientation doesn't change. Okay, you're not making it bigger or making it smaller. So that shape remains exactly in the same condition. All we're doing is pushing it across or up, across and up, or across and down, or you can just push it just across or just up. So your translation is moving the shape, keeping it as orientation in exactly the same position as it was before. C to B, the translation of 4 square to the right. We generally don't say it in words. What we're going to use is vector. Okay, so if you go from C to B to A, we're going 4 square to the right and then 3 square up. That's the translation of 4 square to the right and 3 square up. And we use the vector to describe that transformation. So say you're saying is a translation by the vector 4, 3. What is a translation vector? So in the translation vector, you write down the horizontal distance that you're moving. So anything that you're moving across, left or right. So if you go right, it will be positive number. And if you go left, it would be negative number. If we go up, it would be positive number. And if you go down, it would be negative number. So we're writing down two numbers, the positive x direction over y direction. There is no fraction line when you're writing a vector. Just keep that in mind or make a mental note. There is no fraction line. It's x and then y stacked on top of each other without fraction line. Okay. So what does that 1, 2 mean? That means 1 in the horizontal distance and 2 is vertical distance. Okay. So 1 in the positive x direction. So 1 to the right and 2 up. What does 1, negative 2 mean? It means 1 to the right and 2 down. What does negative 1, negative 2 means? Means 1 to the left and 2 down. So pause the video and match these ones. And when you're ready, press play. Right, so when you're translating it, so this is a question we've been given. This question has been given to us. So translate this shape by vector 4, 2. So what happens to the rectangle here? We're going to move every single point or every single coordinates of that rectangle, 4 in the x direction and 2 in the y direction. So we're moving it 4 places up, right, and 2 places up. So that's 4 places to the right. And then we move it 2 places up. So this is where we get the entire rectangle, 4 to the right, 2 up. And that's translation completed. Okay. Have a look at another example here, regardless of what transformation we're looking at. So translate this shape here by the vector 4, 7. So you're moving it 4 places to the right and the 7 places up. So again, 4 to the right and 7 up. So that top right corner here will go to the top right corner there. And then if you want to draw the shape again, don't make the same mistake that everyone uses it and then redraw the shape to the right. Okay, now that's the top right corner, so the image should have this point as a top right corner. And if you're not sure and if you're struggling to remember that, make sure you match every single one of those. 4 right, 7 up. 4 right, 7 up. 4 right, 7 up. So do that with every single point. And map every single point exactly using this method. And then what you get there is an image. Exactly the same thing here for the second example. -8 and -5. That means you're going 8 places to the left and 5 places down. 8 places to the left, 5 places down. So now this time we got the top left corner. And that's top left corner. And then I can recreate that shape. Remember, the size doesn't change, orientation doesn't change. So from there, I'm going 2, 3 down, 1 across. Use those 2 points and join them up. So that's what we should get. And we get our image, which is shifted 8 left and 5 down. Pause the video, have a go at these questions. So translate that triangle given using the given vectors. Okay. When you're ready, press play. Few more questions for you to try. Again, when you're ready, press play. So if I ask you to describe the translation that takes you from A to C, if I go from A to C, what translation would that be? Okay, so A is your object, C is your image. What am I doing? So I'm going 1, 2, 3, 4, 5, 6. 6 to the left and 1, 2 up. So -6 and 2. So it's a translation by the vector -6, 2. And what translation would that be if you go from B to C? So again, you're going 6 because they are in the same line. 6 and 2 down. So -6 and -2. So it's a translation by the vector -6, -2. So that's a describing translation. Generally 2 marks. 1 mark comes from saying it's a translation. The second mark comes from telling me what the vector it is. Okay. What's wrong with this? Explain why I was wrong. So I'm just going to map the point. I'm going to take this point here and map it with this one. So I'm going 3 to the left, 3 to the right. So it's 3 and then 2 up. So it's 3, 2. So what C got is 2, 3 rather than 3, 2. So she got it wrong way round. Okay, she did X and Y. Swap the X with Y and Y with X. So quiz. So just go through it with me. I'm not gonna take forever to complete that. So if you want to, you can pause the video when you see the question. Okay. What type of transformation is this? I know it's a reflection. That's right. What type of transformation is this? Yes, that's right. It's a rotation. What about this one? That's right. It's a translation again. What about this one? That's right. Enlargement. Okay. How many degrees we rotated? It's a rotation, but which one that matches here out of these? It's a 90-degree anti-clockwise. That's a 60-degree clockwise. Okay, if that distance there seems like is 2 and that distance there is 9. Okay, so which translation is that? So it's 9 to the right and 2 up. Okay, so we generally say X before Y. Okay, across first and then up or down. So again, imagine that seems like that's 4 and that's 7. So 4 to the left and then 7 up. That's right, it's an enlargement, but what's the scale factor? So doing 9 divided by 3, so we know the scale factor is going to be 3. Again, going from there to there, so you're doing 12 divided by 6, so we know the scale factor is 2. If you have to describe the transformation, these are the things you need to look for, okay? So, if the two shapes are the same or not, that's what you need to ask first questions. Are these shapes the same size? If the answer is no, if they're not same size, then you know it's an enlargement. By saying enlargement, you will get 1 mark. If the answer is yes, they are the same size, then it could be either one of those other 3. Okay. Then the second question you could ask, are the shape in the same orientation? Then same orientation means keeping the shape same. If it's yes, then it's translation, because for the rotation and the reflection, orientation changes. So that's a rotation, orientation changes. Okay. And if it's a reflection, you're doing it that. Okay. So orientation changes for the reflection as well. So you know it's a translation. And if it's a translation, you need to tell me the vector. Okay. And then the last question you need to ask, can you turn the tracing paper so its shape looks the same? So when you're turning the tracing paper, if yes, then it's a rotation. If it's a rotation, you need to give me the direction and angle. Okay. And you need to also tell me where the center is. But if the answer is no, then it's a reflection. And if it's a reflection, then you need to tell me where the line of symmetry is. So this is how you actually describe. So start with the same size, then the orientation, and then just need to say, can you rotate it and get the same shape? If no, then it's a reflection. Okay, so we're going to look at some questions where you need to describe the transformations. The first question here, we're looking at describe the single transformation that maps shape P to shape Q. So this is our object and that's our image. How you go from P to Q. That's what we need to look at. Okay. So I'm just going to look at it going back to this table or flowchart. Okay. Are the shape same size? The answer is no. So we know it's an enlargement. Okay. The shapes are not same size. So it's an enlargement. That gets you 1 mark. And if it's enlargement, what do we know? So we need to know about scale factor. The scale factor here is going to be that length there is 1 square box and that length there is 1, 2 and 3 square box. So we know the scale factor is 3. It's going from 1 to 3. So that's done. Now that's your second mark, and third marks we need to look for the center. So if I use a ruler and draw the straight line through the same points on the image and the same point on the object. Okay, so let's look at these 2 points here. So that point there and this point here. The squares are really small, so it's going to be slightly difficult, but we can get there. It's either going to be origin or this point here, 0.5, 0.5. You can look at this point, try and look at 2 lines. We always need to look at just 2 lines on them. Object and image. Same points through the objects and image. And you can see where they're crossing. They're starting from here. So the center is 0, 0. Use the coordinates here in the coordinate system. So that's your third mark. And these are exam style questions, okay? Not necessarily been in the exams, but they are exam style questions. So the next question here we need to look at is again describe the single transformation fully that maps triangle A onto triangle B. So we go through the same flowcharts again. Are they same size? Yes, so it's not enlargement. Are the shapes in the same orientation? So no, the answer is no. They're not in the same orientation, so it's not translation either. And the third question, can you turn the tracing paper so the shape looks the same? So if I turn the tracing paper over, yes, they do look the same. Okay, so I can actually use the tracing paper here that we already used. I can actually use it this part here. So 3 points. So we know it's a rotation. Okay, so I'll get you the first point. So just write that down. Okay, without delay. So it's a rotation, gets you first mark. So what's important in the rotation? We're rotating clockwise and it goes from facing that way to facing down. Okay, so that means it's a 90-degree clockwise. That's the second mark, so 90-degree clockwise. And the third mark, like I said, we need to do some trial and error. So we need to make sure that these points needs to go on there when you're trying to look for the points that matches. Okay, so these needs to be exactly the same distance away. So if I use again 0, 0, if you can see it, hold it there and rotate it. Yes, 0, 0 will map those 3 points onto that. Okay, so there we go, center 0, 0. That's your third mark. Again, trying to draw these lines. Do they make 90-degree angle? Just to be sure. Okay, and those lines should be same length. 2 across, 1 down, 2 up, 1 across. Okay, so they are the same length. Okay. One more question. And this is 2 mark question. So generally translation and reflection have 2 mark questions. Okay, so they're same size? Yes, they are same size. Are they same orientation? Yes, they have the same orientation. Then it's a translation. So that's your first mark. Translation. That's your first mark. And then we need to tell me the vector. So if I map this point here with this point, then you can tell me what the vector is going to be as well. Okay, so we're going, and again we're going from A to B. Okay, you're mapping A onto B. So we're going, A is our object and that's our image. So it's important that when you're doing the questions, you're not rushing through those. Okay, so we're going from A to B. I'm looking to go 1, 2, 3, 4. So we're going 4, translation by the vector 4 to the right. Okay, so 4 positive, and then you go 1, 2, and 3 down. That means -3 in the y direction. So when you're doing the translation, you always do x, then y. Okay, so that's your second mark there. Question 4. We're looking at describe the single transformation that maps A onto B. So this is the last type basically. The orientation is not same. It is same size, and when you rotate it doesn't match. That has to be either pointing sideways, downwards, or both pointing up. Basically that means that you can't rotate it either. So it's a reflection. And if it's a reflection, you'll get 1 mark anyway. And then another mark, where is the line of reflections? Where is the mirror line? Where do I put the mirror? And they both look the same. Okay, so I don't know, you might have a mirror, you might not. So you're gonna try look through the mirror. Okay, can you see where you possibly see the triangle? So does it look exactly the same place where they're supposed to be? Yes. So that's the mirror line there. Okay, can you see that? So that's the mirror line, and the mirror line is this y-axis. So you can say y-axis, or what's the equation of the line? So it goes through the line where x is equal to 0, and everywhere on that line x is equal to 0. So you can also say x equal to 0. Reflection in the line x equal to 0. Next question. So we looked at all 4 different type of transformation. Okay, the last one, then that should be enough for you to actually be comfortable describing any of the transformation. Describe fully the single transformation that maps shape B onto shape C. So this is our object and that's our image. So we're going from B to C. So they are the same size, yes. So it's not enlargement. The orientation is not same, so there's not translation, and so it's a rotation, because if I rotate it, that arrow is going that way. So it's going anti-clockwise, so we know it's a rotation. So that's the 1 mark, and it's going 90-degree anti-clockwise. So 90-degree anti-clockwise. And now we need to find out where the center is going to be. Again, if I get a small piece of tracing paper, and it's going from B to C, so I'm going to draw the B. Okay, and trying to find the point. So try 0, 0 generally, might always work. Might not always work. Yes, in this case 0, 0 works. You can see that. If I rotate that, there, anti-clockwise 90 degrees. So we know the center 0, 0 as a coordinate, and that's the 3 mark questions done. Okay.